Today, I will be trying to answer the question of what is the perfect bowl, using my grade 11 understanding of physics and a lot of extra research. Let's start to analyze the video of the 2019 PBA Bowling Indianapolis Open Final, Norm Duke versus Jason Belmont. Now, the first thing that comes to mind when thinking about important variables would be, don't professional bowlers have their own customized bowling balls? And you would be correct. The only problem is I can't seem to find any details about each bowling ball in 2019. For now, we will assume that bowling characteristics are at least similar to my research, where the typical competitive weight for a bowling ball is around 16 pounds. Right now, we have Norm Duke starting. As you can see, he has a narrow foot stance, minimal knee bend, and an upright posture. There are also helpful visuals and information on the side of the screen. We are given the velocity, RPM, breakpoint, and position at arrows. In bowling, the breakpoint refers to the point on the lane where the bowling ball begins to make its transition from skidding to hooking. It's a critical moment in the ball's motion that can significantly impact the trajectory and pin action. As you can see, this bowl results in a pretty smooth strike. Now let's see how Belmont responds. As you can see, Belmont uses a two-hand approach with a wide foot stance, deep knee bend, and significant upper body lean forward. His ball travels at a higher velocity with over 100 more rotations per minute than Duke did. The visuals on the side shows a much deeper curve, and the breakpoint is much farther away from the position at the arrows. Already we can see the difference in each bowling style. Since Norm Duke's ball falls into the curve, the RPM doesn't need to be as high. Let's look at how Norm Duke's bowling style influences the breaking point and RPM of his ball. The first ball has a speed of 18.5 miles per hour and a rev rate of 423 RPM. Norm Duke's approach is characterized by precision and finesse rather than sheer power. His ball arrows at the position of 6.5. Given Duke's smooth and controlled delivery, his ball is well suited to fall into the curve at the breakpoint rather than needing a high RPM to generate hook potential. This means that Duke's ball reaches its breakpoint at the arrows, matching his release point. This alignment allows him to consistently hit his target area on the lane, resulting in his strike. With Belmont's bowl, we can see that his ball travels at 19.8 miles per hour with 531 RPM and a position at arrows of 19.3 and a breakpoint of 4.3. The combination of Belmont's high ball speed, substantial rev rate, and late breakpoint results in a ball motion that necessitates a considerable amount of hook to achieve optimal pin carry and scoring potential. This late breaking hook allows Belmont to control the back end of the lane, maximizing pin action and minimizing deflection, which also results in a strike. Now, let's analyze when both bowlers hit a crucial shot, a split shot. As we see, on Duke's fourth bowl, he ends up with pins 4 and 9 still up. His approach is to guide his ball to the very edge of the pin 4, resulting in more horizontal displacement to get the pin to jump to the other one. We don't get the values for velocity and RPM, but we can visually tell that the velocity is lower because he wants his shot to be precise, and the rotations are less because, as stated before, the velocity is lower, and the line is more direct, resulting in a successful split. For Belmont, his split takes place on the 10th bowl, where his hook catches early, resulting in pins 3 and 10 staying up. This split is easier to hit because the pins are in steeper relation to each other, not requiring for the pins to have as much horizontal movement, but the shot still takes a lot of skill. Similarly, there is no RPM or velocity given, but we can tell visually that the velocity is much lower, although the ball still has lots of rotation as it travels down the lane. The crucial difference between his split and Duke's would be that he guided the ball in between the pins, letting the impact between the ball and the first pin slightly guide the ball back into the path with the second pin, resulting in a successful split. As you can tell, greater RPM equals higher rotational force. A higher RPM means the ball is rotating more rapidly around its axis. This results in a greater rotational force being applied to the ball, influencing its horizontal motion and behavior on the lane. The increased rotational force contributes to enhanced hook potential as the ball's angular momentum interacts with the lane surface to create lateral movement towards the pins. As you can see, both bowlers and their style of bowling are very effective in multiple scenarios. The end of the game results in Duke winning. The main factor in what makes one style better than the other would be consistency. Duke's method is much more consistent because it doesn't require such a large amount of rotational force, which can be affected by many factors such as lane oil flare, RPM, and velocity. Duke's method allows him to hit his targeted area constantly because the only thing that will stop him from getting an effective bowl would be the bounce of the pins. I think that a more effective bowl would be Duke's stroker method, but I think that the perfect bowl depends on many factors such as the bowler themselves. Until there's some superhuman with a perfect, never-changing stance and perfect throw, the perfect bowl is still out there. Thank you for watching.